Okay, so right now we only have, when we do graphing, right, we only have two types of graph. We either have a U-shaped graph or a N-shaped graph, right? So a U-shaped graph, okay, so the first thing you need to take note is the shape. How to know whether it's U-shaped graph? It's U-shaped graph if the coefficient of the x square is what?
It's positive or
Positive or negative? U-shape. U-shape is like happy face or sad face?
positive.
It's like happy, right? So happy means positive. Okay, so positive. So let's say we have the other one, the other shape. So instead of U shape, the other shape will be
N shape.
N shape. Yes. So if it's a N shape, okay, N shape, that means that the coefficient is
negative.
yes. So we have a coefficient of x square, only x square. I repeat, only which term?
X square.
X square term is negative. So you can write this in your notes now. So I'm going to split the intercept into two kinds of intercept. So remember in linear graph, you also learn two kinds of intercept. So intercept, there's only two kinds, either the x-intercept or the y-intercept, correct or not? So when does x-intercept occur? When does
Y is 0.
very good, when y is equal to 0. So if you want to find the x-intercept, means you need to sub
Sub y equals 0.
into where?
Into equation.
Very good, into the equation, okay? Then what about the y-intercept? What do you have to do?
X equals to 0.
X equals
Sub.
to
Sub
0.
x
X
equals
equals
to 0
0
into
into
the
the
equation.
equation.
Very good. Okay, so now I need you all to go and draw out the graph. I'm going to tell you where it's the y-intercept and the x-intercept. Can you see here? Okay, I'll do a U-shape and I'll do an N-shaped graph as an example. Yeah, so right now, x-intercept, I'll let it be orange. Can you see x-intercept here? So in the one in orange means, can you see here, very unique at this particular point. Means these 2 points here is your x-intercept. Then for the N shape, where's your x-intercept? Can you see this particular point and this particular point? These two are your x-intercepts. Got it? Now, y-intercept will be the next color. So this is your y-intercept, right? So where is y-intercept? Can you see here? The part where it cuts the y-axis. Then what about for the N shape? Where's the y-intercept? This part here, where it cuts the y-axis. Got it?
Yeah.
Now, there is this higher level one, okay? Oops. Here, I call this the floating graph. Can you see the floating graph?
Yeah.
And I call this the floating graph. Okay, the floating graph. This floating downwards. The one floating upwards, right? Now, you look at the one that is floating. Is there any x-intercept?
No.
Means does it touch the x-axis? So this one, right, take note. There is no x-intercept for this person, right? What about the one at the bottom? Is there any x-intercept? Does it cut the x-axis, the one at the bottom?
No.
This one also no x-intercept. But what about y-intercept? Is there any y-intercept for the one that's floating upwards?
Yeah.
Okay. Y-intercept means the one in green. It's actually this point here. Can you see that? I think my green is not prominent. I'm going to make a more prominent green. Here. Is it better? Can you all see? Then what about the one floating downwards? Is there any y-intercept?
Yeah, the bottom.
This part here. Okay, so the one in orange are all my x-intercept. The one in green are all my y-intercept. Got it? Okay, I'll let you all make your notes first before I move on to point 4 and 5. Okay, so my line of symmetry right now, always remember guys, now this one, I'll not let it be pink, I'll let it be red. Okay, now line of symmetry, always take note. I repeat again, always take note because number one, line of symmetry is always in dotted lines.
Huh?
Dotted lines. And number two, line of symmetry has an equation. What is line of symmetry? It's always not y, but rather x. It's always x equal to a number. Got it? Got it, guys? So for example, we have 4 different type of graphs, right? Can you see this is where the line of symmetry? So the red represents my line of symmetry, right now. Can you see that? So can you see that, let's say at this particular point, guys, can you see that this particular point is called 2? X is 2, right? So what is this line of symmetry called? I will write either right on top or right below, okay? Up to you. You can write down the line of symmetry is actually X equal to 2. That's it. Got it? I repeat again. Now I'm going to do the one for the bottom. So look at the wall. Look at here, guys. Can you see this dotted line here? So this dotted line must go all the way down, okay? And all the way up. It needs to cut through. So let's say it cuts through this point called 5. Now, so what is this line of symmetry called?
X equals to 5.
Yes, that's it. Done. Finish. Got it? So let's say we have here now. Can you see at this particular point, this is my line of symmetry, right? Line of symmetry means where the graph is symmetrical. Okay? So let's say at this particular point is 1. So what do you think this line of symmetry is? For this person, guys. What is the line of symmetry?
X equals 5.
Thank you. X equal to 1. Okay, what about here? Can you see here? There's a line of symmetry here. Let's say this person is 10. So this line of symmetry will be called
X equals to 10.
X equal to 10. Finish. The end. Next, the last one is we're going to do turning point. Now for turning point, okay, I'm going to use purple to represent. Now turning point, there are 2 types of turning point. If let's say it's a U-shaped graph, okay, where is the turning point? The turning point is here. Okay, I think it's a little bit small. I'm going to draw bigger. Can you see this, guys? U-shaped graph. The turning point is the lowest point for this U-shaped graph, right? So this has a name. This particular point will be called the minimum point. Minimum point because it's the lowest point, right? Now, what if it's an N-shaped graph? Where would your turning point be? So can you see your graph turns at the one at the cross here?
The maximum point?
Yes, and this is called the maximum point. So you can start making your notes, and then I'm going to go more in depth in the ones that I drew in black. Okay, so turning point is always in a coordinate form. Meaning, turning point, okay, oh dear, I have not enough space. Okay, turning point, guys, see here, is always in a coordinate form. So I'm going to write it down. It's in a coordinate form. When it's a coordinate form, I'm talking about like bracket x, comma, y. Okay? Coordinate form. So coordinate form means we need 2 values. We need the x value and we need the y value. Got it? So usually turning point, right, occurs on the line of symmetry. I repeat, turning point always occurs on the line of symmetry. Okay. So next time I'll go more in depth on how to find the line of symmetry. Maybe later I will do it, but right now I'm going to do the turning point first. So the turning point is in the coordinate form of x and y, right? For example, I'm going to do the one in purple. Can you see the turning point is this part here? Can you see, does it occurs on the line of symmetry?
Yes.
So remember, coordinate is always, turning point is always in a coordinate form. So do we have the x value already?
Yes.
How much is the x value?
2.
Yes, 2. Now what about the y value? Okay, the y value, guys, look at it. Can you see where my dotted line is? Dot, 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 dot. Here. So let's say here is minus 10. So my answer will be 2, comma,
Minus 10.
minus 10. Who is lost? All okay? All good? Now, what about this person? Guys, can you see this turning point right here, the one in purple? So what it will be my answer be?
5.
5, comma, then I don't know, right? So let it be maybe
9.
9, okay? 5, comma 9. Got it, guys?
Yeah.
Understand now?
Yeah.
Okay? Okay, now let me backtrack to the line of symmetry. Now, line of symmetry occurs on the when you have the x-intercepts, okay? So for example, Can you see that this x-intercept is called 5?
Yeah.
And this x-intercept is -1, right? So how do we find the line of symmetry? Okay, line of symmetry, can you see that to find the line of symmetry, I take the average of the x-intercept. Okay, this one is in orange, average of x-intercept. This is one method to get the line of symmetry. Meaning, can you see the x-intercept is 1, -1? So I take -1 plus 5. Average means take the total and divide by 2, right? So -1 plus 5 gives me 4. And 4 divided by 2 will give me 2. And that's how I get x equal to 2. Got it, guys? Okay. That is one way to find line of symmetry. So what is the first way to find line of symmetry? By taking the average of the x-intercept. That is one way to find the line of symmetry, right? Now, there is a second way. The second way to find the line of symmetry is, guys, do you notice this one here? Do you notice that here got no x-intercept? So a lot of students tell me, Miss Lin, I don't have x-intercept, I cannot find my line of symmetry because there is no x-intercept. You need to teach me that line of symmetry has to come from the x-intercept. No. Doesn't mean that it always comes from the x-intercept because there is another way to find the line of symmetry. So the line of symmetry can come from, number 2, the turning point. Got it? Why? So can you see this person here has no x-intercept, right? But can you see that this is a turning point here? So do you think we can find the line of symmetry here? Let's say my turning point here is 10, -2. So what will be my line of symmetry? My line of symmetry always occurs on the turning point, right? So it cuts at 10, correct or not? Because you see the x value is 10. So the line of symmetry will be x equal to 10.